Guys, this is the fourth part of the video for the Cloud KMS. In this video, we are basically covering message authentication, uh, code signatures. So as we know that the Cloud KMS is basically used to create and manage encryption keys, which is used in many compatible services in Google Cloud services. And we can generate software or hardware keys. We can import keys into Cloud KMS or link external keys like from external key management system, which maybe many organizations are using to store their keys. And we can use customer managed encryption keys in multiple Google Cloud products using with like CMAK integration. And we can use keys or KMS keys to create a verified digital signature or message authentication code signature. So in this video, we are working on message authentication code signatures. So when you create a key, there are multiple purposes for which you can create a key. So once a key has been created, the purpose cannot be changed. Purpose will always remain the same. So as of now, we have covered symmetric, asymmetric signing, asymmetric encryption, raw symmetric encryption. I cannot show because of some limitations, but the last which is pending is MAC signing. So in this, we will cover about MAC signing. We will see what is MAC signing and how to create that MAC signing. So what is a MAC signing? MAC signing basically is a signature, the cryptographic output which is used to verify integrity and authenticity of the data. So it has two parts. First is signing operation, second is verification operation. So first operation is signing operation. So basically in this we use a signing key to produce a MAC signature over raw data. So suppose you have some data and you want to create a MAC signature. Uh, so for creating a MAC signature we need a signing key. From that signing key come from Cloud KMS. When we create a key, there is a purpose which I have talked about. So the purpose is MAC signing. With the help of this, we create a MAC signature over our raw data. We will see how to do. And the next part is verification operation. And in this, we will authenticate the message. It can be authenticated by using two things. First of that thing is signing key. Signing key, which is we create with the help of our link Cloud KMS and the MAC tag, which is generated here. You can see them when we ever do a signing operation, the MAC tag is generated. So with the help of these things, we will do the verification process. We will see how to do that. Basically, whenever you do a signing operation, you will share a MAC signature with the other person and the data and the raw data. And he will do the same thing and check whether the same tag is generated or not. If the tag is not generated, different tag is generated, we can say that data is altered, someone has compromised the data. So the purpose of MAC signature is similar to digital signature. It's accurate similar, which we have checked in our previous video, but there is one specific thing which we have to remember. It works on symmetric cryptography. So in the process in which have seen in digital signature, we use a key pair, public and private key pair, but there is no public and private key pair. There is only one key, and the sender and receiver both have the same key, and they will use the same key to verify the data that we have passed over to to sender or receiver, and the MAC tags that are generated and verified using the same secret key, and sender and receiver of the message must both have the same key to use MAC signature. It cannot be happen like sender a different key and receiver a different key. That doesn't work because it is a symmetric key. Same key has to be used for the same purpose. So how it is works? So first thing, signer and the recipient receives on a specific shared MAC key. So like any sender or receiver, they will create a key from in the Cloud KMS. After that, the signer performs a sign operation over the data to compute a MAC tag. He will run some command and a MAC tag will generate it. After that, the signer will provide the data and MAC tag to the data recipient. So the sender will like share the data like from like multiple source of sharing data and the MAC tag to the recipient, and recipient use the shared MAC key which we have generated through Cloud KMS to verify the MAC signature. If the signature comes accurate same over the raw data, then we can say data is not altered and it is successfully verified. But if the signature is failed or signature is different, we can say the data is altered. This is the process. We will see how to do this, all these things. And this is the Cloud KMS resources we have already seen multiple times. Keyrings like first of all you need a keyring to create. Before creating a key, we need a keyring. Like in your house also, we have a keyring in which we have multiple keys. After that, keys can have multiple versions. Type can be symmetric or asymmetric. Purpose can be multiple purpose. Like these are all the key purposes. After that, primary version, if you are using symmetric key, then only is a primary version. Otherwise, there is no primary version. And even Mac sign-in doesn't support primary version. You can create multiple version, but there will be no primary version. These are multiple state which we have seen already multiple times, and the algorithm, which algorithm you want to use. So let's start our demo and see how it all works. Cloud KMS, and this is my keyring, my demo keyring. I will go inside it. I will click on create a key. After that, let let's call it Mac Mac key. After that, we have three production level software, HSM and external. You can choose any one of these which you find well. So software is like cryptographic operation performed on a software level. HSM, cryptographic operation performed on hardware security module. Basically, the kind of physical machine inside a Google premises. It is very costly also because it for each version it costs about $1 to $3, and it is very kind of cheap software one. And after that we have external. External means you have a external key manager residing somewhere else. Maybe you're already using your organization. You can just connect that over internet or via VPC. I don't have EKM, so I cannot show you how to do that. But if you have, you know, this is a very simple thing. Just follow the documents. So I'm going with software only. Click on continue. After that, there are two options: generated key, imported key. Generated means Google will generate a key for you. Imported means you will import your own key. So import your own key means customer supplied encryption keys. So customer is supplying their own encryption key, and generated key means customer manage encryption keys. So customer is managing their encryption keys. And for import, I will try to create a video. Next video maybe. After that, the algorithm purpose. So there are, for if you are using a symmetric, there is no algorithm we can change here. But for all other, we have multiple algorithms. So we are going with max signing verification. So there are multiple algorithm. You can choose any algorithm according to your organization, like which security or which SHA level they want to use. So all provide different kind of security and hard to break. So I'm going to SHA 256. After that versions, we cannot rotate a key in this because there is no automatic key rotation. Just click on continue. After that, duration of scheduled destruction. So if you don't provide any value, it will automatically delete it after 1 day. But soon it will be 30 days as per the Google documentation. So before deleting any key, first of all, you have to disable that key and see if any data which is encrypted with that key facing any issue. So at least you must know that something is encrypted. So decrypt that data and encrypt with the new key. And even after disabling and move to destruction state, is put that key in some more days, like 10-20 days. So if some issue occurs, you just restore your key and decrypt the data. Because once the key is deleted, you cannot do anything. Then Google doesn't support on this. They have a strict policy that once the key is deleted, the data is lost because you cannot decrypt it. You can add a label also, like for an which why you are using, like for any specific purpose. So just I will click on create. So my key has been created. Let's go inside of Mac key. Let's see what's the option. There is no option. You can see there is no option public key because it is a symmetric key. So there is no reason there will be a key pair of public and private key. Uh, After that, we have overview, and we have users tracking, so we can check who is using our key permissions we have. I have not enabled users tracking. So now let's have our demo. So basically, this is my uh, cloud shell. So I have a file here mac.txt. If I do cat. So this is a testing of mac sign, only this. And this is the command which we are going to use. So first of all, we have to provide a key version. So key version can be, you can get it from here. So if you want to create multiple key version or more key version, so you just click on create version. It will create a new version. It will give a version name 2. Even if you want to edit default key algorithm, you just click. Suppose in future you want to use a different algorithm, just click on that. Let's select this 384. Click on save. and click on create new version, and it will create a version with 384 one. You can see now we have three version, but we are going with, you can choose any version of these which you want to use. All like depends upon you. So choose any version of these. So I will going with version 1. So I will provide it key version 1. After that it asks for a key name. This is my key name, Mac key. I will provide that. After that it will ask key ring. You can click on overview. You will get a key ring. This is my key ring. After that it will ask location, which is Asia South one, and it will ask us the input file. Input file is our mac.txt, and this is my signature file. So it is sign.txt, which it will create. It is net it is not created yet, but it will create. Let's go and run this command. So command has been ran. If we do ls, we can see sign.txt. We have our file. That means it is working fine. We have created a sign.txt. Now we have option to verify whether it is good, fine or not. So this is the command for verifying. So we have to update the key version. Key name we can just copy from here. That is known as Mac. We have created Mac key. Key ring is demo ring. After that location is Asia South one. Input file path. So input file path is mac.txt, and the sign file path, it is sign.txt. So it will just verify whether data is same or not. So let's go. We can see, you can see it is saying true, means it is okay. So let's do one thing. I will modify my data. So to nano mac.txt, and I will say comp and save it and run that command once again. It is saying none. So means it is not verifying that our data is same. So let's go, means it is altered. Now we have another option to verify the data is altered. There's two options. This is the first option to verify, and there's one more option. What we can do now, let's go back and nano mac.txt, just remove it. Suppose you have sent this data to some other person in your organization, and he want to also check whether data is altered or not, whether he can run this command, or what he can run. He can run this thing again, this command again on the same data. So he will run uh, this command again. Just I am getting the file name sign.txt. So this has been done. Now what he can do, he can run a command diff sign.txt and sign.txt. If it give any thing, any difference, means data is altered. So if a tag is not giving any issue, it is giving no output. That means data is same. There are the two methods which you can use. Whether you can just verify it, or you can just rerun that command and in your point and check whether data is altered or not. These are the two things which we can do. As we can see, you can rerun, that means create a tag and verify the tag which you have provided by someone, or while transmitting the data you have one more options. You can just do encryption of all the data. Like once you have created a data, create a symmetric key. What you can do, you can re-encrypt data. Like you can use a symmetric sign to create a encrypted data. So when you forward the data over the internet or anyone, So no one, if even someone get the data, no one can compromise without the key. So once you get the data, decrypt the data and then run the MAC signing to verify the data is altered or not. This is the best process you can do. There are multiple process, multiple things you can use. Just think of it how you want to use this all data in your environment. Just any question, just ping me out or reach out to me or comment it out. I am happy to help you. Thank you.